Hello again. In this lecture, we're going to examine NumPy's statistical order functions. These will include PTP, percentile, and quantile. We will explain where the names come from and how to properly execute the functions themselves. All right, let's go right ahead. As always, we start out by importing the NumPy library and defining the matrix A array again. Okay, now that we have our array displayed on the screen, we can go through the different functions. The first function of interest is PTP. It's short for peak to peak and returns the difference between the highest and lowest values within an array. We can call it right now to see the range of values within matrix A. The result is 9, and we'll see that it's correct if we examine the matrix displayed above, since the max is 9 and the min is 0. Of course, we can obtain these two values by using NumPy's min and max functions. However, it's very convenient and time-saving that we can find the range of values by using one function instead of two. Just like the other functions, we can also execute PTP along an axis. You're already aware of how adding this parameter can influence the output. So you shouldn't be surprised that executing the next two code cells will deliver specifically these two arrays as an output, right? Good. Now that we've shown you how you can use PTP, let's move on to the next function we're interested in, percentile. As the name suggests, this function returns a specific percentile of a given set, and unlike PTP, it requires a second input, percentile, apparently. Before we try to execute it, let's quickly explain what this percentile is. A percentile is a value that is greater than the corresponding percent of the dataset. For example, the 70th percentile is greater than 70% of the data. Another way to look at this is that we're 70% through a sorted version of the array. Let's elaborate these statements. To have a basis for comparison, we can first use NumPy's sort function on matrix A and have the axis argument set to none. This will ensure sort takes the flattened array as an input and sorts it in increasing order. We'll explore the sort function and its syntax in greater detail in about an hour, so we can just focus on the output for the time being. Great! Now that we have this in front of us, let's find the 70th percentile of the data in the matrix. We write np.percentile and add matrix A, 70 in the parentheses. The output is between 4 and 5, and if we look at the sorted array above, we'll see exactly why. Since we have 15 values, then 70% is the same as the 10.5th element. Hence, it's somewhere between the 10th and 11th elements of the sorted flattened array. Since these values are 4 and 5 respectively, the percentile is somewhere in between. In cases like these, where the percentile is between two values of the dataset, it's up to us to decide how to compute it. The default for this function is to use linear interpolation, which creates a number that is some fraction of the way between 4 and 5. If we always want our outcome to be halfway between the two values of the dataset, we can set the interpolation argument to midpoint. That's why, as we execute the code now, we obtain 4.5. You see? Then, if you want to select a value from the dataset, you can change it to higher or lower, which would set the percentile value to 5 and 4 respectively. Great! Finally, if you don't feel too confident with always going for the lower or higher number, but still want a value that is present in the dataset, you can set interpolation equal to nearest. This essentially rounds the intermediate value and sets it equal to whichever of the two dataset values is closer. And that explains why we obtain 5 in our example. Hence, we recommend using nearest as your interpolation argument specification. Of course, doing so ensures that the output of the function will be of the same type as the input data, since it's taking a value from the array. To test this, we can use the type function and see that the output in this case is an integer. However, if we don't specify the interpolation, it is calculating a fraction by default, so we get a float. Since this could potentially affect our results in the future, we need to keep track of what interpolation we set when computing the percentile. Wonderful! And what do you think will happen if we wanted to examine such values as 0, 50, or 100? If we set the percentile equal to 50, we get the median of the set. If you don't remember what the median is, it's just the middle value of a sorted dataset. If we set it to 0 or 100, we get the minimum and the maximum of the array, respectively. Great job! Before we wrap up, we also want to examine the quantile function. So quantiles are very similar to percentiles, but they don't express what percent of the sorted array we've gone through, but what part of the set we've covered. Hence, the 70th percentile and the 0.7 quantile for the same set should be identical. In terms of syntax, the only difference between the two reflects just this. The percentile function takes values between 0 and 100, while the quantile function between 0 and 1. That said, let's find the 0.7 quantile of matrix A. We simply write np.quantile and plug in the name of the array followed by the quantile. The result is identical to the one we initially had for the percentile function. So if we want the two functions to be consistent, we can set the interpolation argument equal to nearest here too. Fantastic! Now that we've learned how to use the statistical order functions in NumPy, we're ready to move on to ones which compute other important statistic of datasets like averages and variances. In the next lecture, we'll explore how to use median, average, and similar functions to extract information about the dataset. Thanks for watching!